There are three rules that I want to talk about in this video. The first one is going to be about cyclic quadrilaterals. Now, we have two examples of quadrilaterals inside circles here. So here I've got a quadrilateral where I can see that the corners of the quadrilateral touch the circumference. Here I've got a quadrilateral and three corners touch the circumference. Okay, so this corner as well touching the circumference. And then the other corner is going to the center. Now, when we talk about cyclic quadrilaterals, this is an example of one, and this is a non-example. Okay, so this one is not a cyclic quadrilateral. So this is a non-example, I would say. Okay, so whatever rules we have about cyclic quadrilaterals will work for this one, it will not work for this one. Now, the rule for cyclic quadrilaterals is this. So when we have opposite angles in a cyclic quadrilateral, so A and D here, so I can say A add D is equal to 180. Okay, this is always going to be true for a cyclic quadrilateral. Opposite angles in a cyclic quadrilateral add to 180. Also, if I look this way, C and B also make 180. So C add B is also equal to 180. With my non-example, I can see E and G are opposite each other, but I can't say that they will make 180 because this is not a cyclic quadrilateral. F and H are opposite each other, and I can't say that these will make 180 because these are also not in a cyclic quadrilateral. And I can actually see that this E looks like an acute angle. This is an acute angle. I haven't drawn this accurately, but we can sort of see that this is an acute angle, this is an acute angle. Two acute angles will never make 180. This looks like an obtuse angle, this looks like an obtuse angle. Two obtuse angles will make more than 180. So I can see that it won't be true for this example that I've drawn here. But for this one, it is true. Okay, so you can see that these two will be 180, these two will be 180. And even though I haven't drawn it accurately, you can sort of see that we have an acute angle here, obtuse angle there, obtuse angle there, acute angle here. Now, our second rule is for angles subtended by a chord on the same segment are equal. So what I've drawn here for you on the top here is I'm showing you what a segment is. So this thing that I've drawn here with red highlighting, this is a segment, okay? And then the other part of the segment is on this side. So this is a segment, and this is a segment. Sometimes we call this one a minor segment, and this is the major segment, okay? So you need to know that when I have a chord, the chord splits the circle into a minor segment and a major segment. Now, what I mean by angles subtended by a chord on the same segment are equal look like this. So if you remember, when we subtended angles at the center from the chord and another one at the circumference, the one at the center is always twice as big. But suppose I do lots of them to the circumference, all of them must be the same. Okay, so this is what it would look like. So if I draw an angle here, so this angle here would be the same as an angle drawn here as well. Okay, and again, I can do it again, maybe on this side. So all three angles that I've marked here, they will be equal. And why do we say same segment is because if I was to do my angles on the other segment, all of the ones on the other segment will be equal to each other, but they won't be equal to these ones. And all of these ones on this segment will be equal to each other. So this segment, let me highlight this one again. So I've used the major segment here, so the bigger side. Okay, so you can see that from my chord, I've subtended three angles at the circumference of this major segment. Okay, I didn't do it on the bottom side, on the minor segment. I did it on the top side. So all of these will be the same. And you can see that I could have actually done so many more angles like this. Okay. Now, suppose I wanted to do it at the bottom side. If I do it to this diagram here at the top. So if I draw an angle here, so this chord subtends this angle there, and also I can draw one on that side there, this angle. These two angles will be the same. And again, this time I'm subtending from the same chord, but on the other segment, okay? So on the bottom side, on the minor segment. So I can say now the angles subtended by a chord on the same segment are equal. So when we subtended on the same segment on this side, they were all equal. When we subtended on the same segment on this side, these two are equal. The final rule that I'm going to be talking about in this video is the alternate segment theorem. So let's think about how that works. So we need a tangent and we need a point here, and we need what's going to look like a triangle. Okay, so a triangle where the points of the triangle are on the circumference. Okay, and I've done it twice so that we can see it in two different ways. Now we need to stop thinking about the triangle and start thinking about alternate segment theorem. So the segments. So the alternate segment theorem will say that if we have a chord like this one and a tangent, okay, so let's highlight all of this. So the chord and the tangent, okay, so the chord and the tangent are making this angle on this side, okay. Let's do it in the other color. So this angle, and what happens is this segment here on the bottom side, so the tangent and the chord have made this angle, and this angle is the same as the angle on the other segment, okay, so alternate segment. So this angle is the same as the angle that's made on the alternate segment by the same chord, okay. So this chord is subtending an angle on this major segment here, and this angle would be equal to this one there, okay. So that would go there. So if I say this is x and this is y, x will always equal to y in this situation. On the other one, we can mark an angle on this side. So this chord and the tangent have made this angle. And let's now highlight the alternate segment. Okay, so the alternate segment is all of this bit here. So this is the alternate segment. So I have here the chord and the tangent making this angle, and the angle that the chord makes on the alternate segment, it can be at this point, it can be this point, anywhere around here on this segment, this angle will be the same. So this angle will be the same as the red angle that I've drawn here. The two red angles are the same. Your task is to find the missing angles and write down the rules you used in full. Okay, so state exactly what rule you used, write it in a full sentence. You need to find all the missing angles. So for question 1, there's 2 missing angles here. We've got 2 here for question 2. We've got 1 here, and we've got 3 in this one. Now, remember, you may sometimes need to find other angles that I have not marked in order for you to find the ones that I have marked, okay? So pay attention to that as well, and make sure you use the rules correctly. Now, all of these, I have attempted to draw circles. The center has been marked as well for all of them. Every line, anything that looks like a line, I've tried to say that this is a straight line, okay? So this here is a straight line. This is a tangent, okay? Tangent here, that's a chord, that's a chord, that's a chord. And then here we've got radius, radius, chord, and a chord. And the same can be said here. The lines, I am saying these are straight lines.